On my last episode, I asked the question, does hot water freeze faster than cold water? And I asked the question and I did a little experiment to see, but I did miss a couple of important things when I talked about it. The first is that I didn't define what I meant by freezing. What I was trying to get to was whether hot water and cold water reach 32 degrees, the freezing point, in a different amount of time. That was my intent, and that's exactly what I was able to show there. Now, there is a principle called thermal equilibrium that explains this to a large degree, and I didn't mention that. That was the other thing I was missing. So I thought on this video, I would take it one step further and talk about when the water becomes ice. What happens? Which one becomes ice faster? It's kind of taking that a little bit further than I had talked about last time. I was trying to answer a simple question, but I didn't get into the details, so let's do that now. After about 5 minutes of sitting out, I just wanted to show you this. The one that was cold water to start, it's still pretty well frozen. You don't see a lot of air going through it. The one that was room temperature, this one, you can see that there's a fair amount of air in it, and the water has separated a little bit, and you have a little bit of water that's come out, and it's actually separated out a fair amount. And the one that started out as hot is even more of that it's actually released a lot more of its liquid. So it's interesting, after a couple of minutes out of the freezer, how different they are. It's kind of intriguing in a way. And a couple of minutes later, I dumped them out of the containers. This is what's left of the one that was the hot water. It was almost all liquid when I dumped it out. This is what's left of the one that was cold water. You can see it's a nice brick, though in the middle, there's no water. It's got a hole in it and there's no water inside, so it's actually hollow inside. And the one that was room temperature, it actually kept the shape too, but it's much more brittle. So what conclusions can you draw from that? This one's actually pretty hard. This cold one actually stayed pretty cold. That's remarkable. So you can see that the cold water actually froze to a block of ice faster and more efficiently than the hot water did. I read someone from Physics Today said something along the lines of, I can't determine whether this is trivial or illuminating.